everyone, welcome back to my channel. So in the last video we discussed batch normalization. So if you have ever felt that norm distribution, let's see normalization, it's not a good for small batches or sequential data, you are not alone. Today let us keep deeply into the layer normalization, which is a technique powering models like BERT, ChatGPTs, and the other LLM models. So, layer normalization is like batch normalization. Let's see, the close, let's say, cousin. So, instead of looking across the batch, it looks within a single sample. So, across all its features. So, that this means it doesn't care about the batch size. So it's perfect for transformer, RNN, and even for online learning setup. So when to use this layer normalization? So here's when to go with layer normalization. It's after linear or self-attention layer, and don't use it. It doesn't depend, let's say, on a batch size. It works with even a single sample. This is the good of layer normalization. So when training transformer and RNN, and also anytime you want to consist behave in the training and testing. So because we will see in the last section, we also calculate we did the normalization and calculate the mean and the standard deviation for training and also for testing. It's not like the batch normalization. And you can see here it's ideal for text sequence and a small batch size, even compatible with stochastic gradient descent and Adam. It's like the batch normalization. So why we need it? So it's just like batch normalization. It's help your network to train faster, converge smoother, and avoid, let's see, wild gradients. But layer normalization takes a step further. No need to track running statistics. So no surprise during the interferences. So you don't need to keep all of this the mean and covariance for the running for the all batches. So as you can see here, assume that we have, I'm just using the same example. I have 10 batches, and let's see, each one has 3 channels, and each channel is, let's see, the dimension of each channel is 2D, is 32 by 32. And let's say I have here 1, 2, 3, and let's see, assume that I have 10, because I have but here. So how is this working here? So in the batch normalization, we collect all each channel. Let's say, for instance, red channels and calculating the mean and covariance for this, and also do the standardization. Now it's not like this. So here we need each sample. So for instance, this sample will be taken alone. This sample will be taken alone, and this and this. So it's not regarding any batch. It's only channel. And you can see here, for instance, for each sample, because we have from 0 to I mean from 1 to 10, from 0 to 9, and each sample, it has 3 times 32 times 32. This, for instance, for this, the input size, for instance, this one here. And as you can see here, number of values in each sample is 33,072 value. And we will start with the first sample because we have 10 samples. We will start with the first one. And for instance, we have 3 channels here, and we will try to, let's say, flat the image into one-dimensional vector, or let's say tensor, and compare the mean and the standard deviation as usual. And now normalizing the data and applying, for instance, for the scale and shift. So it's similar to the batch normalization. And now we will do it also for the second sample, because we have here 10 samples, and until finishing this, we have this is, let's say, for this, for example, n sample, which is in our case is 10. It's the number 10 sample. And what's happening in the training and Yeah, hopefully this is should be clear. So let me just recap this. So we will try to first flatten the image, because not the image. It could be, for instance, a feature map with several dimension. But I'm just trying to keep it easy for you. So that's why I'm just using image. Compute after flattening the image, or let's say the feature map, compute the mean and covariance normalization, then apply learn scale y hat and scale and shift, let's say. And this is simple and elegant, and exactly what like GPT do under the hood. This is what GPT doing. So for the training, what happening in the training and sorry, I did some mistake here. So this should be, so this is layer, but you can see because of the copy and paste, sometimes we get issues. View mode. And remember how batch normalization changed the behavior between the training and inference. So it's trying in the batch normalization, we save the average running of the mean and covariance. But here it's not. So layer does not do this, or saving the. It's compute the statistics per sample in both during the training and also shifting. And testing or inference. So no shifting behavior, or no need to for running average. So this is only, let's see, a final tip. So when you should use, let's see, reach the LayerNorm. It's good for small batches, for NLP task, and also for online learning. So it's consistent, optimized, friendly, and battle test in all the big models. So batch normalization, it changed the game, but the layer normalization brought it to the next level. If you are building anything from chatbot to translation models, so this is you go to this is you need to go for the layer normalization. So if you like this, please subscribe into my channel, like the video, and if you have any question, please drop it down in the comment below. Thanks for watching.